Welcome to the second topic of Module 2, Microscopy. We will begin by discussing the various parts of a microscope, whether it be a compound light microscope or a stereo microscope, and the interactions with light that allow a microscope to form the images that we see. We'll also discuss the definition of several of the common terms when we refer to microscopy, things such as magnification, field of view, the working distance, and depth of field. We'll discuss the differences between the optical light path of a stereo microscope and a compound light microscope, and then also discuss how a polarizing light microscope works. We'll also define refractive index, a common term that's used with many of the forensic samples in identification, and also various instruments that have microscopic abilities. A forensic scientist must select the correct analytical methods depending on the sample that they're trying to analyze. Most of the analysis involves either microscopic or instrumental methods. Our second topic will discuss microscopy. Forensic microscopy is the use of a microscope in an investigation to assist with establishing facts or evidence for a court of law. So why is this so important? Microscopes are used in almost every section of a crime laboratory. Usually they are used as the very first tool that might be applied to a piece of evidence. So, for instance, in a drug section, an analyst may be working to help identify a specific pill. They may use a stereo microscope to look closer at the markings on the pill, where a trace analyst might also use a microscope initially when they're examining a pair of shoes to try to identify any small glass particles that might be in the soles of the shoes. So usually it's used as one of the very first tools on all different types of evidence. The analyst can use these microscopes to help locate different evidence. They might also use it to collect evidence from different items, or they may use it as a portion of their testing. The basis of microscopy is the interactions of white light with various objects. Visible light or white light is going to interact with those objects or the surfaces of those objects in different manners. It can either be diffuse light, reflection, or refraction. Diffuse light is going to be reflected uniformly in all different directions, where reflection or refraction is going to be more dependent on the materials themselves. With reflection, that light is going to strike the surface and then leave the surface at exactly the same angle. With refraction, the light is going to change directions as it passes through the sample. Microscopes use these terms, reflection and refraction, in several different combinations so they can redirect the light so that you can better visualize samples. They do this by using a series of different lenses. The lenses that are used are either going to be concave lenses or convex lenses, depending on how the light rays actually need to be exiting or entering samples or exiting or entering different lenses. The microscope through the use of different lenses, is going to create either real or virtual images so that that final image can be relayed to the viewer's eyes. A virtual image is formed when the incident and the reflected rays converge behind the lens. A virtual image will appear at the equal distance behind the lens as the item is in front of the lens. A real image is going to be formed when the incident and the reflected rays converge in front of the lens. So a real image will appear at a distance dependent on the actual placement of the object itself. A virtual image is going to be a representation of that actual image that we see. However, the image itself cannot be captured on film, where a real image is also a representation of that actual object formed, but this image can be captured. It's actually visible. The microscope itself uses a series of lenses to visualize the images through the use of magnification and resolution. So exactly what is magnification? This is the process by which lenses are used in combination to make objects appear larger. This occurs because of the refraction that is created from the lens. It produces a virtual image which makes the image appear larger. Magnification of a simple lens can be described by the following equation. In reality, we commonly think more of magnification as the height of the image over the height of the object, or in more practical sense, if you have a 1 centimeter line that is viewed at 2 times power, it's going to appear as a 2 centimeter line. In most instances, when we think of magnification, we think of the combination of the lenses of a microscope. The main lenses of a microscope that provide the magnification powers are located in the ocular or the eyepiece of the microscope and also in the objective lens of the microscope. So to obtain the total magnification of a microscope, you combine the 2 powers of the lenses. So if you have a microscope that has 10 times power in the eyepieces and 25 times power in the objective lens, your total magnification of that microscope in that setting is 250 times power. We also talk about the resolution of a microscope, and this is the measurement of how well the smallest details of an image can be discerned. In practice, the microscope will have a numerical aperture value, and this value is determined by the equation shown. The total resolution of the microscope combines the numerical aperture of the objective and also of a substage condenser. In the forensic laboratory, a wide variety of microscopes are used. Depending on the section of the laboratory, they may use a simple microscope, which would be a one-stage lens system, something very similar to a common magnifying glass. Or they may use compound light microscopes, which are two-stage lens systems, either a stereo microscope or a compound light microscope. Several sections also use comparison microscopes, where it's either two compound light microscopes or two stereo light microscopes that are connected with an optical bridge. This allows the analyst to see images from two different microscopes in one field of view. There are also several specialized microscopes that are used in the trace evidence section of a crime laboratory. These all provide different information about the samples that the analyst is testing. There are several different instruments available to the forensic scientists that also have microscopic attachments. The stereo microscope is commonly used for the initial examinations of evidence, and in some cases it may actually be used for the analysis itself. This microscope provides very low magnification. It's usually anywhere from 20 times power to 60 times power. The microscope itself provides very good depth of field. It allows you to see images in three-dimensional viewing. Most stereo microscopes also have a very large working distance, which allows the analyst to look at a lot larger samples. Initially, this is used for a lot of initial examinations to actually find small pieces of evidence, to collect pieces of evidence off of items, or there are some instances where the stereo microscope is the actual analysis tool. In firearms sections, there might be projectile or cartridge casing comparisons that are done on a stereo microscope, or tool mark comparisons are also done on a stereo microscope. The compound light microscope provides higher magnification. Usually the compound light microscope will be either 40 times power to 400 times power. This microscope provides good characterization for the morphology of a sample, but it also allows you to view a lot of the internal features of that sample itself. So this microscope is used for a lot of different identifications of different samples. It's used primarily in the trace evidence section or a forensic biology section. It's used for a lot of hair comparisons, fiber comparisons, evidence such as this. The compound light microscope has a wide variety of different portions to the microscope itself. Starting at the top of the microscope, there are eyepieces or oculars that work in combination with the objectives to provide the total magnification of the microscope. This allows you to see the specimens clearly. The oculars are usually placed on a mechanical tube that allows the light to pass through to the objectives. The objectives are the second component that provides the magnification in addition with the oculars of the microscope. And the objectives also have excellent optical performance and are usually produced to provide corrections for any aberrations in the lenses of a microscope. There are 6 different common aberrations that can be found in lenses, and the objectives are usually built to correct a lot of the different aberrations. All microscopes are designed to include a stage where the specimen is placed for observation. Depending on the microscope itself, there are a variety of different stages available. Stages can be designed to actually hold microscope slides or to have the flexibility of actually moving the microscope slides. There are also stages that can hold smaller samples, such as those when your bullets or projectiles are examined, or some stages that have a larger area that could hold various things in your tool mark examinations. Directly below the stage of a compound light microscope is a substage condenser. This helps gather the light from the microscope light source to concentrate it to the sample on the stage of the microscope. This is the one component of a microscope that is in a compound light microscope, but that a stereo microscope does not have. And finally, the microscope will also have a light source available to the unit itself. This is going to provide bright, glare-free light to the sample. Most microscopes that are used in the forensic lab, the compound light microscopes, are going to be set up to provide color illumination. This is a setting of the microscope so that there is focus points between the various lenses of the microscope. This specialized lighting is going to provide uniform, bright, and glare-free lighting to the sample itself. To set up color illumination, there must be several focus points in the optical light path of the microscope itself. The focal points are beginning with the lamp filament itself, then to the sample, to the back focal plane of the objective, and then to the viewer's eyes. Microscopes are going to use the various lenses to provide a combination of either reflection or refraction to redirect that light path to visualize the samples so that characterization can be done on the samples. One of the first characterizations of samples that is done is to study the refraction qualities or properties of that sample itself. Refraction is when there is a change in direction as light passes from one medium to another. This occurs because there is a change in the speed of the light as it passes from one medium to another. The refractive index is a numerical value that defines this change in the speed of light as it passes through one medium to another. And as you can see from this slide, there are refractive index values that are known for both liquids and solid materials. So it's a very common property that can be used to help identify various forensic samples. When using a compound light microscope, the analyst also has the ability to use polarized light to examine samples and determine the refractive properties under polarized light. Polarized light is light that vibrates in only one plane. This is created by the insertion of two specialized filters into the optical light path of a compound light microscope. The Polaroid filters are placed directly below the sample, and then also another filter placed between the objective and the oculars. When viewing samples under crossed polars, they might exhibit different properties. Samples that demonstrate optical properties that are the same in all directions are called isotropic. However, samples that display optical properties which vary with the orientation of the light and the material are called anisotropic. So these are two additional characteristics that can be determined for many of the samples that a forensic scientist analyzes. In addition to whether or not the sample is isotropic or anisotropic, the birefringence can also be determined for the samples. The birefringence is a numerical value that is the difference between refractive indices of a sample. Also, interference colors may be displayed for some samples under crossed polars. There are several specialized microscopes that are also used in a forensic laboratory, primarily in the trace section of the laboratory. A phase contrast microscope uses special optics that help enhance the identifying refractive index properties of samples. The special optics provide additional contrast to the samples. A fluorescence microscope uses specialized filters to visualize any fluorescent properties that a sample may display. And a microspectrophotometer uses special lighting to obtain information specifically about the ultraviolet or visible properties of a sample. The microspectrophotometer uses special lighting to obtain these UV and visible properties of the sample. So it's primarily used in the visible region to see or test the colors of the samples themselves. A lot of samples will also have characteristics in the UV region that the microspectrophotometer allows the analyst to compare. Some microspectrophotometers will also have a fluorescence unit attached to it, so it can also be used to view fluorescence of samples. This microscope is primarily used on paint samples, fiber samples, and ink samples. Another specialized microscope is the scanning electron microscope, or SEM. Most scanning electron microscopes used in a forensic lab will have two different detectors on the instrument itself that will provide additional information to the analyst. The analyst is able to view the samples under a lot greater magnification than your average microscope, but then they can also determine elemental composition of the sample itself. Once again, this microscope is primarily used in the trace evidence section of the laboratory, and it's used on a lot of different small particles, gunshot residue, paint, and glass. Next, we will talk about the instrumental techniques and methods that are used in a forensic laboratory.